Good evening, students. As we discussed earlier at the chapter 1, and coming to the in chapter 1, we have learnt about what are the Mos and Bicmos CMOS technologies, and what is Bicmos technologies, and how the fabrication is done. This entire process have been discussed in chapter 1. And coming to chapter 2, here it is about basic electrical properties of Mos and Bicmos circuits. So in this chapter, what the electrical properties we are going to discuss. So the electrical properties here are current and voltage mainly. So these are the electrical properties, basic electrical properties we are having. So the electrical properties of Mos and Bicmos circuits. Mos and Bicmos circuits means that is current and voltage. That is current and voltage relationships of Mos and Bicmos circuits. So, as we are discussing about the current and voltage relations of Mos and Bicmos circuits in this chapter. So, and already we have know that we are having in Mos transistors we are having three terminals, that is gate, source and drain. So, as we are applying the voltage across the gate to the channel, what is happening? The channel will be established between the drain and source. The channel will be established between drain and source, but there is no flow of a charge carriers between the source and drain. So, here the movement of charge carriers will be done only by the application of the voltage VDS, that is drain to source voltage. So by application of the drain to source voltage, there will be a movement of charge carriers from drain to source or source to drain. So here the channel will be established in enhancement mode transistor only whenever we are applying the voltage on the gate. So here, so as we see here, the first topic here coming to this is drain to source current, that is IDS versus voltage relationships, that is IDS versus VDS relationship is the first topic in this second chapter. So here how we are deriving the relations, that is IDS in IDS versus VDS in non-saturation condition as well as saturation condition. So here coming to hear this, as I have been said that there is only the application of voltage on the gate, only there will be establishment of channel between the source and drain, and after that there will be an influence of electric field that will be done or created only by the application of VDS between the drain to source, that is VDS. So from that we can say that IDS is equals to, if we see the equation, that is 2.1 here, IDS is equals to charge induced in the channel, that is QC, by electron transit time tau. So IDS is equals to QC by tau. So here the tau again it can be written as tau is equals to length of the channel L by velocity V. Tau is equals to length of the channel L by velocity V. So as we substitute this relation of after in this, so coming here, but velocity what is having? We are having velocity V is equals to mu into EDS. V is equals to mu into EDS, and here EDS can be written as VDS by L. EDS can be written as VDS by L. So here velocity V is equals to mu into EDS. Mu is nothing but electron or hole mobility, and EDS is nothing but the electric field which is applied between drain to source, and that electric field EDS is equals to VDS by L. So we are substituting all these relations in tau. So what happened? What we are having tau? Tau is equal to L by V. So tau is equals to L by V. Here tau is equal to L by V. What is V? V is nothing but mu VDS by L. So if we substitute here, what happen? What we are getting the relation tau is equals to L square by mu VDS. See, here I have done it in clearly. Say check. So here we are having IDS is equals to what? That is minus ISD, that is equals to QC by tau, that is charge induced in the channel QC by tau, and I am writing here the transit time tau is equals to L by V, and that is length of the channel by velocity, and but velocity v is equals to mu into EDS. I am assuming this tau is equals to, this is the first equation, and velocity, that v is equals to second equation, and we know here the mu is nothing but electron or a hole mobility, and EDS is nothing but the electric field between the drain to source. Okay, and here the EDS is equals to what is VDS by L, VDS by L. So substituting this, what we are getting, V is equals to, velocity V is equal to mu into what is EDS, VDS by L. So what we are getting, the velocity equation, V is equals to mu into VDS by L. This is the equation. So I am substituting my velocity value in the transit time equation. In transit time, what we are having, transit time tau is equals to L by V. So I am substituting the velocity value in the transit time. So tau is equals to what happens, L square by mu VDS. I am assuming this as some equation. So here coming to the non-saturation region. In non-saturation region, what happens is, here the average value, that is what happened is VDS by 2, and the gate voltage is VG is equal to VGS minus VT, and the charge per unit area, that is equals to what, Eg into epsilon insulator into epsilon naught, that is permittivity of free space and insulating material. Okay, so total charge induced, QC is equals to what, Eg into epsilon ins into epsilon naught into WL. So here this is the QC, and in that Eg, what is Eg? This is nothing but here Vg minus this average value. Actually Eg is equals to Vg minus average value. So what is Vg? We are having effective gate voltage VGS minus VT, minus average value is nothing but VDS by 2. So by D, this is the Eg value. So I am substituting now this fifth equation in fourth equation, that is total charge induced. So QC already we are having, QC is equals to Eg. We have to substitute this Eg value in this QC. So into VGS, so we are getting QC is equals to what, WL epsilon insulator into epsilon naught by D into VGS minus VT minus VDS by 2. This we are getting the equation QC. Now I am substituting, I am assuming this equation as seventh equation. So now I am substituting this sixth and seventh equation in A. That is we are deriving the relation of current and voltage, IDS versus VDS. So what we are having, the IDS, we are getting the IDS relationship. So what we are having, the IDS is equal to QC by tau. So we already got the QC equation here, and and we are having the tau relation, that is tau, how much we are getting, sixth equation, that is tau is equal to L square by mu VDS, and already we have got the equation QC also. I am substituting the QC and tau in the IDS equation, that is IDS is equal to QC by tau. So I am substituting the QC equation as well as the tau equation. I am getting the IDS in terms of VDS. So IDS is equals to, if I am substituted and I calculated here, so I got IDS is equals to this much factor, and I am assuming this total constant factor, that is epsilon insulator into epsilon naught into mu by D as K. So I am substituting this constant K value here, and again this K into W by L is equals to, I am assuming the factor beta, and I am writing in terms of this VDS and IDS relation. IDS is equals to beta into VGS minus VT into VDS minus VDS square by 2. This is the IDS value. And coming to the saturation region, it begins whenever the VDS is equals to VGS minus VT, which means that as we are increasing that VDS voltage more, what happened, the current, it becomes the constant. So here we are having the VDS is equals to VGS minus VT only, and we are having the average value 0. So directly we are getting the equation IDS is equals to, directly I am substituting. So K is already, we know this, epsilon insulator into epsilon naught into mu by D, and W by L into VGS minus VT whole square by 2, and K into W by L again we can written as what, beta. IDS is equals to beta by 2 into VGS minus VT whole square. This is the IDS versus VDS relationship of Mos and Bicmos circuits. So this relation is very important relation. This relation is exactly from this I have derived in the separate paper, and you can check this You can check this here also. And this is what the non-saturation region. Again we are having everything here. Epsilon, what is epsilon insulator, what is epsilon naught, what are the values and derivation, everything. And this is total non-saturation derivation. And again here if we see the 2.4a equation, after 2.4a equation we are having Cg, that is Cg means here we are having the channel capacitance. So here IDS, not only IDS versus VDS, we can write it in Cg, that is parallel plate capacitance also if you want. Otherwise no need, only we can end the equation at 2.4a for non-saturation condition, and for saturation condition we can end at 2.5a here. So it is enough. So this is for saturation and non-saturation. This is a very important long question. IDS versus VDS relationship is very important long question. There will be no question paper without this question. Okay. If you have any doubts, please ask me in the group. Okay. Thank you.